In this video, I'm going to go through solutions to the first three problems on the worksheet, and I'll save the next three for a separate video, but you should probably watch them back to back. Now, before I get into the solutions, and being as this is the first worksheet of the semester, and this is a class about algebra, let's just talk about this term algebra. What is algebra? Now, the term algebra refers to mathematics, math, in which we use symbols to represent numbers. And that's basically it. Now, there's a lot of specific things that are happening in algebra, equations and graphing and solving, but in general, algebra, the distinction between algebra and other types of math is in algebra we're using symbols to represent numbers. Basically temporary placeholders. Now those symbols could be anything. Letters, shapes, little smiley faces, it doesn't really matter as long as you define what they represent. Now, normally we don't use little smiley faces, we use letters. And our standard letters, you know, an X or X and Y or maybe an N, those are the common symbols that are used to represent numbers. So in this first problem, translate into an algebraic expression. That means translate the statement in English into a statement that is made up of letters, numbers, and mathematical symbols. So those letters, we call those variables. So a variable is a symbol, namely a letter, used to represent a number. Okay, so let's look at this problem. Alex had $Y before spending $22.50 for a book. How much did he have after the purchase? There's nothing to solve for here. There's no numerical answer. The goal here is to just translate. And translate is a very important word because when you're doing a word problem, that's exactly every single word problem you will ever do. You have to translate from English into mathematical symbols. So that translate step has to happen first before you do any solving. So translate this into numbers, symbols, and mathematical expression or mathematical operations, plus, minus, times, divide, and so on. So let's look at this in a more general sense before the specific values in the problem. This person Alex is spending money, and so if you think about spending money, you have some money, you spend some, you end up with less. So the key word here is spending. Okay, so that means taking away the $22.50, removing the $22.50, or subtracting the $22.50 from what you start with. So if we think about this as, you don't have to make a chart like this. You know, there's many ways you could write up a solution to a problem. I'm a very visual learner, so I like to have everything written out in charts and diagrams and labels whenever possible. So let's think about the situation in general. We have some amount of money that's before he bought this book. Then there's some money that is spent. And then there's some money left over after the purchase. And so what are we given and what is unknown? Well, Alex had $Y before spending. So that means, okay, he's starting with some money. We just don't know how much. We're using the letter Y as a temporary placeholder for the number of dollars he's starting with before the purchase. Then he spends $22.50. And when you spend money, again, it's taking it away from what you have. So the spending in this case means subtraction. So we're subtracting $22.50. So what is he left with afterwards? Well, he's left with whatever he started with minus the $22.50, and that's dollars, and that is an algebraic expression. And again, the reason it's an algebraic expression is because it contains a symbol, it contains a letter. So the number of dollars he had left over is Y minus $22.50, whatever that is. If he started with 100, you know, think about it. If you have $100 and you spend $22.50, what do you have left? Well, 100 minus $22.50. If you start with $50 and you spend $22.50, you're left with 50 minus $22.50. And if you're starting with any number of dollars and you spend $22.50, you're ending up with 2250 less. So that would be the algebraic expression for this problem, and that's the final answer. All right, so let's look at number 2. It's actually a very similar problem, except in this case we're actually solving the problem, and we don't have to use algebra. Now, and that's actually an important point to make. Just because this is an algebra class, you don't have to use algebra for every single problem. Again, the definition of algebra, using symbols to represent unknown numbers. So the only time you need to use symbols in your calculations or in your equations is when something is unknown. All right, so let's read the problem. And now, one thing I want to caution you is that one of the biggest mistakes I find students make, not like calculation mistakes, but in terms of your approach to solving word problems, one of the biggest mistakes I see is impatience, being in a hurry to start calculating things. There's a very famous problem-solving technique. It's been around for about 70 or 80 years. There was a Hungarian mathematician named George Polya, and he was the first person to basically write down a step-by-step guide to solving word problems, any word problem in general. It's a 4-step process, and doing the math doesn't even happen until step 3. So, step 1, familiarize yourself with the problem. Read the problem again. Step 2, devise a plan. Think about what you can do, what you should do, what you're looking for, what's known, what's unknown. And then finally, once you fully understand the problem and what information you have to work with, then start doing the calculations. And then step 4 is just a final thought. Does my answer make sense? So you should, I urge you not to just read a problem and then start, plugging things into your calculator. It's really important to sort of create a framework for what you're going to do first. Okay, so a football team gained 11 yards on one play, lost 37 on another, and gained 34 on the last play of the first half. They had already gained 299 yards during the half. What was the total yardage gain for the first half? Well, it looks like there's some important information here that we could point out. So there's gained 11 yards. So that looks like it's addition. So you're gaining or you're receiving, so that's increasing your amount by 11. So that looks like plus. Then lost 37 yards on another. So lost 37, that looks like subtraction. And then gained 34 on the last play. So that again looks like addition. And they had already gained 299 yards during the first half. So they already had 299. So it looks like they're starting with 299. So it's very similar to the last problem where we looked at the starting amount of money and the ending amount of money. In this case, it's the starting amount of yards and the ending amount of yards. So let's say start, finished, and let's say during. You could label this however you want. And again, this is how I like to do problems. I like to actually write everything out because, again, I am a very visual learner. So one thing I'm gonna note first is that you definitely don't feel like you have to use numbers in the order they appear in the problem. I'm going to start with a 299 because it says they had already gained 299. So before these 3 plays happened, they were already starting with 299 yards. And then during those 3 plays, it looks like there was a gain or a plus of 11. Then there was a loss. So take away or subtract 37. And then finally, there was a gain of 34. So starting with 299, it increased by 11, decreased by 37, then increased again by 34. And if you plug this into a calculator, 299 plus 11 minus 37 plus 34, you will get a grand total of 307 yards. And so in this case, that would be our final answer. And so you see, I'm taking a long time to explain this, but I want to be thorough, particularly because this is the first video, the first time I'm working out problems. In my future videos, I won't be spending so much time talking about the approach and what is algebra and this and that. But I think it's important to lay some groundwork in terms of the framework we're going to be using to solve problems. Now, one last definition I want to give you is, what is math? Okay, so, and it's very surprising to me that, in the last, 17 or 18 years that I've been teaching, it's almost never does a student give me a correct answer. When I say, what is the definition of math? Well, you're a college student, so you've been taking math for years and years. You started in elementary school, you had math in middle school and high school. Almost every year of grade school, you take math. And I always find it interesting that by the time you get to college, most students, actually almost all students, could do math, but they can't tell me what is math. Now, I'll give you my definition of math. Mathematics is, this is the definition of math, the science of patterns. The science of patterns. That is mathematics. Now, what does that mean? Well, let's say, what does it mean in the context of an algebra class? When I think about patterns, I'm not thinking about patterns in numbers. I'm thinking about patterns in problems. So to me, problem 1 and problem 2 were almost the same problem. We're presented this situation where we have the starting value, then something happens, some change, and then there's a finishing value or an ending value. So I want you to think about these problems. We're going to cover a lot of them throughout the semester, not as individual isolated problems that are not related to each other, but there's a handful of different types of problems, and then there's some slight variations between them, but we're going to be using the same approach to solve many, many, many different problems, or problems that sound very different but aren't really very different because we solve them the same way. Okay, so mathematics, the science of patterns. Now, let's move on to number 3, which is the last one for this video. A machinist has a flat plate of metal that is 8.141 centimeters thick. He laminates the metal plate with 4 more layers. Keyword there, more. That means an increase or addition. 4 more layers that are, so let me just underline the more, that are 1.430, 2.755, 4.712, and 3.032 centimeters thick. He then grinds off, so grinds off, removes, subtracts, grinds off. So let me do green, 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 and green for addition. I'm using green for addition and red for subtraction. He grinds off the 1.697, then 4.235, and finally another 1.237. Find the new thickness of the plate. So this looks like another situation. So it looks like these 3 problems are all very, very similar, almost the same problem. There's a starting value. Then there's some change that happens. Then there's an ending value. Okay, so it looks like we're starting. A machinist has a flat metal plate that is 8.141 centimeters thick. He then laminates the metal plate with 4 more layers, so addition. So adding 1.430, adding 2.755, 4.712, and 3.032. He then grinds off, so subtract 1.697, then grinds off 4.235, then grinds off 1.237. Okay, so that's the change that happens, and the question is, find the new thickness, or what's the ending thickness after all of these things, all these changes happen. So again, this is something I've already done on a calculator, but we would take 8.141 plus 1.430 plus 2.755 and so on. So we would add four numbers, then we would subtract 3. You could do that all in one step in the calculator, hit enter or hit equals, and finally you would end up with, according to the calculator, 12.901 centimeters. And that would be the final answer. So you'll see, upon first reading them, this is 3 separate problems, 3 different problems, but it looks like we took the exact same approach to each of them. That's why I say mathematics is the science of patterns. And I want you to think about patterns in terms of how you do things, how you approach word problems. If there's, if you see 15 word problems on a test, which you'll see in the final exam, I don't want you to think about those as 15 completely different problems that have to be done 15 completely different ways. There's going to be many similarities between the problems. Okay, so that's it for this video. I'll give the next 3 solutions on the next one. From here on out, the videos are going to be a bit more streamlined because it'll be more talking just based on the specific solutions and less of this overview of algebra. All right, hope this was helpful.